this video, we will talk about reduction of order. Okay, so look at the problem first. So basically, the purpose of the reduction of order is like whenever your first solution is given, then we're gonna try to find another solution from like given solution. Okay, so like y1 is given, then we're gonna double check like y1 is really your solution. Okay, here we go. So differential equation. Then to do so, we need y1 prime, which is minus t to the minus 2, and also we need y1 double prime, which is minus plus t to the minus 3. Okay. Then we're gonna plug in everything to the given differential is 2t squared times 2t negative 3 plus 3t and right. It is 4 t to the minus 1 and minus 3 t to the minus 1 minus t to the minus 1. That's exactly 0. Then we just checked like given y1 is the real solution. Okay. Then now we have to think about like another form of solution. Okay. So we're gonna consider y2 as vt y1 t4. Okay. So like the purpose is that we have to find y2. For that purpose, we have to find function v, which is multiplied to the like given equation, right? So this is equal to v times t to the minus 1. Okay. So like we have to make this y2 is really working for differential equation, right? So we need y2 prime, where we have to do the product rule, v prime t to the minus 1 plus v times negative t to the minus 2, right? Which is v prime t to the minus 1 minus v t to the minus 2, right? And also we need like double prime as well. Like both of them must be like taken care by the product, right? So, okay, first part, v prime prime, which is v double prime times t to the minus 1 plus v prime times negative t to the minus 2, right? And second one, minus v prime times t to the minus 2 and minus v times negative 2 t to the minus 3. Let me simplify. It is equal to v double prime over t. Let me write it as the fraction form, minus v prime over t squared minus v prime over t squared. Oh, we can combine this two, right? And plus 2v over t cubed. Okay. Then finally we can have this guy. Okay. Now it is time to plug in everything into the given differential equation, which is 2t squared y double prime plus 3ty prime minus y equals 0. Okay. Plug in all the y2 prime and y2 double prime. Okay. T squared times y double prime, which is v double prime over t minus 2v prime over t squared plus 2v over t cubed plus 3t times v2 prime, which is v prime over t minus v over t squared and minus v over t. Okay, so like we would love to find the function v which is satisfied this one. Okay, so let me simplify. Okay, here we go. Then multiply this one. It is 2t v double prime minus 4v prime and plus 4v over t. Then what our second one? Plus 3v prime minus 3v over t and minus v over t. Right? Look at that. At this moment, you have to easily find like all the v term will be gone. So 4b over t and minus 3v over t and minus v over t is gone. Okay. Then, like the next equation, we are not going to have term, I mean v term, but we have like a v double prime and v prime only. Okay. Negative v prime came from negative 4v prime and 3v prime. Okay. Then look at that. Now it is time to use the reduction of order. What does that mean? If I define u as v prime, then this second order equation by as the first order equation, okay? And like now, we will try to solve this differential equation, okay? And as you can see, this is like first order linear equation, so we can use integrated factor, or it is separable, so you can use separable as well, okay? So in this video, we're going to use the integrating factor, okay? So let me divide by 2t on both sides. We assume like t is not equal to 0. And u prime minus 1 over 2tu is equal to 0. Is that clear so far? Then now, like integrating factor, mu is e to the integral pt dt, right? E to the integral, your p is negative 1 over 2t dt, right? Which is equal to e to the minus 1 half ln t, right? This is equal to e to the ln t to the minus 1 half. Then we can say, simply we can say t to the minus 1 half, okay? Like, with this one, we can easily find the u function, okay? ut is equal to 1 over mu t integral mu t gt dt, right? Plug in everything. 1 over t to the minus 1 half integral t to the minus 1 half times your g is 0. Oh, it is 0, right? So you don't have to worry about this guy, right? So which means it's constant, okay? It is c over t to the minus 1 half, or we can say just simply c times t to the 1 half. Is it clear so far? But keep that in mind. We are not going to try to find u, but we need v to complete right to right. What is v? Actually, like u is v prime. Then we can say your v prime is equal to c times e to the 1 half, okay? So let's do the integral one more time, okay? Then my v is equal to c times 1 over 3 half 2 to the 3 half and another constant d, which is equal to, well, look at that. This is just constant, right? We can combine as one single constant. We can say c times t to the 3 half plus d simply, okay? And almost there. Now we can find y2, right? Here we go. Equal to, like, it was v times y1. So it is c times t to the 3 half plus d times y to the minus 1. Then finally we can say it is c times, oh, not y to the minus 1, but t to the minus 1. That's what I'm saying. T to the 1 half plus d times t to the 1 half, okay? But you know what? Like at this moment, I do not write y2, but I'm just writing y, right? Because, like, look at this one. Like, this part is y1, right? Then like whenever you make the like in linear combination form, and this d times t to the minus 1 will belong to y1 part. In other words, we can say this guy is your y2. Okay, so finally I can say my y1, which is given by t to the minus 1, and y2 is t to the 1/2 now. Okay, when we find these two, then we have to double check these are really form the fundamental set of solution. Okay, so how can I do it? You have to use the Wronskian. That's a really important part. Okay, okay, just w y1 comma y2, it is equal to determinant of y1 y2 or y1 y2 and y1 prime and y2 prime. Okay, let me plug in everything. Okay, y1 is t to the minus 1, and this is y2, and y1 prime is negative t to the minus 2 is 1/2 t to the minus 1/2. Okay, so that is equal to t to the minus 1 times 1/2 t to the minus 1/2 minus minus plus t to the 1/2 times t to the minus 2. Let me write like this way, like to help you on this. Okay, minus t to the 1/2 times minus t to the minus 2. Okay, that is equal to 1/2 t to the minus 3/2 and plus t to the minus 3/2, which is equal to 3/2 t to the minus 3/2. Okay, in the problem at the beginning, we say like your t is positive, so we can say simply we can say your Wronskian is not equal to 0, then which means the conclusion of this one is 1 and y2 form the fundamental set of solution. Okay, okay, that's it. Then my general solution is this one, y2 to c1 times y1, which is t to the minus 1, and c2 times t to the 1/2. That's it. Thank you.